So my name is Sam. I work as a software engineer here at Mundimoto. I guess you've all seen the bikes downstairs. I was also going to explain a bit what we do, but I guess you can guess what we do. Anyway, let me introduce the company first, a bit of context. This is, so I will stop looking there because I have the slides in my phone. This is what we are and what we want to become. We started this company in 2019, and we are quite young, but ambitious. We want to be the top-selling and buying motorbike startup in Europe. That's the plan, but you know things don't always go as planned. However, this is how we are doing. Not bad at all. This is the amount of bikes we have sold in the last 16 months. As you can see now, well, this past month we sold about 10 times more than what we were selling a year ago. So the company has experienced a lot of growth in the last year in a quite short period of time. And the idea is to keep up with this pace. So if you see, the curve is becoming steeper. When I saw it, this kind of change in the trend reminded me of something that I had seen somewhere else, and specifically in the interview I did here. I don't know if you've heard about Kent Beck, but he's an intelligent guy who has this theory about different phases in the product development, in the product life. And he says that every product has 3 phases, which are called explore, expand, and extract. And everything can be divided into those 3 parts. So first one is explore, and here's where you take the most risks. You need to find for something that gives you a return of your investment, and then you try to reduce costs as much as possible because you're experimenting, you're trying different things, and you try to strike gold. You don't know if you'll be successful, so you don't want to put a lot of resources on that part. You need to make sure that your product will be successful. Then you move to the next part, which is expand, and this is where things usually go nuts. You've found something that is really giving you money, and then your product has exploded. You start finding bottlenecks where you didn't expect. You're growing really fast, so you only have time to fix whatever you have already in place. And then it gets to a point where it stabilizes, and this guy calls this the extract phase. So the shape of the problem and the solution are clear, and you focus on economy at that point. You try to fix problems which at this point are small, and then try to deliver your service at the lowest cost possible. So each euro or dollar that comes in becomes $5, $6, $10 when they go out. And how does this translate to software? So it's kind of a one-on-one relationship. Software was also in an explore phase at the beginning. We needed to move fast. We needed to try see if this was going to work. So a lot of concessions were made. The stack at that time consisted on PHP, Laravel. We had the website on Firebase, and the stock was handled with Monday, that thing in there. I don't know if you've heard about it, but it's kind of a spreadsheet on steroids. So you can guess that this was not the optimal solution for the long term. This worked for a while, but you've seen the volume of sales that we have right now. We are going steeper up, and we are entering in the expand phase. So our services weren't ready to handle this kind of volume that we have now. And then we sat down, we started discussing how we could improve this, if there was a way to improve it. We asked ourselves things like, how can we increase the test coverage, which was not that good at the time. Write code that was maintainable, iterate fast enough to keep up with the business, and also deliver continuously. So after a lot of discussion, we decided to throw everything away and start from scratch. We decided to switch to Python and Django for our backends. And if you're curious, we are using Next.js for the front end of the new website, and also React for some of our applications. And although the company had already been around for some time, this was kind of a new beginning, again, in terms of software, because this was a new project. We wanted to start from scratch. And usually that time is when you know the least about the problems you will face in the future. You just have a set of ideas, and you start throwing them around, brainstorming. We didn't want to lock ourselves into an architecture that we had come up after deciding to use these technologies at that point in time, when we didn't know that much about how our software would evolve. So we wanted to build a system like this without being tied to, for example, the Django ORM or any other technologies that we used. What did we do? Well, we thought about an architecture that worked for us, or we hoped it worked. It was, spoiler, inspired by hexagonal architecture, but we tweaked it a bit so it fit our needs. But the idea still remains the same. We tried to put the inputs and outputs of our system at the edges of the system. Each component that we build only knows about their neighbors, and we build everything using layers. So for example, the business logic layer should not depend on whether we are exposing a REST endpoint or if we are using GraphQL, whatever. We shouldn't care about that at the level. And also we shouldn't depend at that point on whether we get the data from a database, we get it from another API, or we get it just from a CSV file. And this pattern allows us to isolate the logic of our application from outside concerns. So having it like that means that we can easily change our data source. So if, for example, we stop reading data from Monday and we want to switch to another database, we can do that without a significant impact on our code base, or without taking so much time to change everything. And one of the main advantages that we also saw doing this was testing strategy. So the majority of our tests can be run and verify the business logic without relying on outside protocols that we do not care about. So let me explain a bit. Let's start from inside out, and I'll show you how we build it. Let me just drink a bit first. So we have models at the core of our business, entities, but Django calls them models, so we went with that name. These are the domain objects, and they don't care about where they are stored. They just keep the data for the things that we care about. In this case, for example, a motorbike. Then we have our use cases. I don't know if this can be seen, but I can read that for you. We create motorbikes and edit motorbikes in this layer. Use cases are classes that orchestrate and perform the domain actions. So they implement the business logic, the business rules and validation specific to that domain. Then we have repositories. On top of that, you can see that we search by license plate. We get our reservations for the bikes that we've sold. These are the interfaces to get models and change them. They contain some methods that communicate with data sources, and they return either models or a collection of them. So hexagonal architecture, if we followed it by the rule, it says that models and repositories should not be this much coupled. We shouldn't be using models from repositories. But in our case, we decided to do it this way. We found out that it was much easier to work with Django if we did it this way. And although we are a bit more coupled to the library this way, it has worked for us right now. When I was looking for some inspiration to giving this talk, I found out a Medium article, which was exactly what I was looking for. It was called something along the lines of implementing a system using hexagonal architecture using Django. And it said, read time 1 minute. So I went there, I clicked, and the only contents of the article were, how do you do it? You just don't. I saved you a lot of time. So yeah, this was a bit of a concession that we made to make our lives easier. This is the outer layer. We store our interactors in here, event emitters and subscriber, repositories, logging, views. This consists basically on adapters to different storage implementations. It stores how we fetch and push data to our system. So other stuff that lives here, as I said, API views, whatever logging that we have, and also the event emitters and subscribers. And on the outermost layer, this is where we have the external services that interact with ours. And as you can see, everything points inwards. So here, our interactors, whatever they are, can be triggered to perform the business logic. We treat them as an input to our system. Usually the most common transportation layer is HTTP APIs and a set of controllers that handle these requests. But by having the business logic extracted into these interactors, we are not coupled to a particular transport layer. We do not need to always use REST or GraphQL, whatever. So the interactors can be triggered not only by a controller, they can be triggered by whatever thing. Cron job, either you're just playing on your local machine from the command line with a more traditional layered architecture. So instead of everything pointing inwards, we would have like all of our dependencies point in one direction, each layer depending on the layer below. So the transport layer would depend on the interactors, and then the interactors would depend on the persistence layer, and so on. The way we've done things, all the dependencies point inward, so the core business logic does not know about the transport layer or the data sources, but it's still, the transport layer, for example, knows how to use interactors, and also the data sources know how to conform to the interface of the repository. So with this, we are prepared for the inevitable changes that happen when our systems grow. And when that needs to happen, the task of, for example, swapping a data source for another one is quite easy to accomplish. You don't need to rewrite half of your code base. This may seem nice and shiny, but how do we make sure that in a system like this, where you can swap parts of it, everything works as expected? Well, with testing. We split this kind of in three parts. So first one is the core test that we have. We test our interactors and repositories that perform the business logic on the models. We test the views. We validate that what we get is proper data, clean data that we can use. And also we handle the edge cases. We mock responses as we see that we need here. And also this is where the business logic is tested in detail. This is what we try to have the most type of tests of. Sorry, I forgot about showing this before, but you can see some examples of tests, the kind of tests that we have in this layer. We also try to have pretty descriptive test names, so we don't have to add doc strings or whatever. Then we have a second pillar of our testing, which is data sources. Yeah, it cannot be seen that much, right? Well, I can read them for you if you want, or I can show you later the code. We test data sources to determine if they integrate correctly with other services, whether they conform to the repository interface, and check how they behave when there are errors. So this approach works wonders with Django because you get a free in-memory DB. You don't have to worry about that. You don't have to worry about configuring everything. It just works. So this is also one of the reasons we chose, for example, Django instead of Flask. And lastly, we have the integration specs that go through the whole stack. From the transport API layer to the repositories, they check the data sources, they hit the downstream services. These specs test that we have wired everything correctly and everything works as expected. So forget the typo in the class. It's not a view test. It's just calling the view and checking that everything down to the model works, everything is created in DB and so. So with a proper architecture and some testing, we know that we can go confidently into production, but it hasn't always been like this. As I said, before we made some concessions, and the deployments weren't something that we were very proud of, let's say, because releasing stuff was a pain in the ass with the previous infrastructure. So how did it look like? Well, you wrote some code that hopefully worked, because not everything was tested. Then the responsible for that release had to notify everybody else to not touch everything, because they were deploying. Run a command on their local machine to deploy the new code. This froze the person's machine for about 30 minutes. So during that time, they could go have a coffee or maybe pray if that was a risky change. And if everything went okay, which wasn't always the case, changes ended up in production. Things have changed a bit now. How does a deployment look now? Well, it looks like a green button in GitHub. Click a button and see the magic happen. But also, seeing that this button is green means a bunch of stuff. For example, you can see that here we have an approval from Carlota in this case, which was the code reviewer for this pull request. And also that we have some pipelines, CI and CD, that have passed. This allows us to go into production with confidence. Let's see this a bit into detail. So we've set up continuous integration and continuous deployment pipelines. We are using GitHub Actions for this because our code lives in GitHub. So it was pretty straightforward. Every time a pull request is open, the CI pipeline is run. It processes all the checks, verifies that the code can be integrated into the main branch. And then after merging that branch, we run this, which is the CD pipeline. This runs the code and deploys it into production. In our case, it's AWS. You can see some spoilers in here. But let's dig a bit deeper. So you can see that we run some linting. We run the whole test suite. We build the Docker image. We configure Kubernetes, and then we verify that everything is alive after that. We knew we wanted to support our current traffic levels, and we also wanted to plan for the best and for the worst at the same time. So when we were discussing this, this sounded a lot like scaling problems. So we ended up deciding to use Kubernetes. For those of you who are not familiar with it, it's kind of an open source system to manage these kind of things, applications around multiple hosts. So it provides some mechanism to deploy, to maintain. I'm just reading it out loud from their website, and scale applications. Basically what it does is allows us to scale either horizontally or vertically, depending on our needs. And these Kubernetes pods are deployed in AWS. This is how our infra, sorry.
Have you ever had problems before using Kubernetes, like not scaling enough or something?
Not yet at the point we were in the company, but with the plans that we have and what we've seen, we wanted to have something that we don't have to worry about in the future. So yeah. And in the end, well, I was going a bit of a spoiler again, but yeah, you'll see. Yeah, ask me again later if you want. So this is a typical application, a typical system here that we built. Frontends are either deployed in S3 with React, or as a Kubernetes pod also, using EKS, which is the jargon that AWS uses for this thing. We are using two frameworks, React for client-side rendering, and if we are building an application that uses server-side rendering, we use Next.js. And for the backends, as you saw, we do Django on Python. These APIs are deployed inside Kubernetes pods as Dockerized images. And for services that require database, we use Amazon RDS, in this case, MySQL. And if we require some kind of storage, we use S3 too. So Kubernetes services are running in EKS. There's an application load balancer. If you know about Kubernetes, it's called Ingress. Basically, you configure it one time and then forget about it. You redirect all the requests there, and it handles automatically where should they go, to which pod. Yeah, this is called ingress in the Kubernetes world. Do we need more horsepower on our APIs? We increase the CPU or the memory. This is a template of one of our services. If we need to handle more traffic, we increase the number of replicas. Now we have 2 for some of the stuff that we have. And if you've never seen this, it may seem a bit complicated. I won't lie. At the beginning it is. The learning curve is a bit steep at the beginning. So I had a note here about if it was worth it. If you asked me maybe a month ago when we were struggling to setting it up and running it, I would have had doubts. Now I think it was the right approach. We have everything ready, set up as templates. So when we want to deploy a new API, a new service, we just change some names in there. We just hit, if we want to test it from local, this apply deployment.yaml, and it just works in less than a minute. Just some learnings to wrap it up. After some months of implementing this, just wanted to give you something that you can go home and think about it. What can you do to have a scalable application in production using Django and Python? I think that the first thing, and the most important one probably, would be knowing where you are in this curve. Maybe some of the decisions that we've made make sense for us now at this point in time, but wouldn't make sense maybe 6 months ago or 2 years in the future. But still, wherever you are, spend some time thinking on the proper architecture that best fits your needs. It may seem that you are slow at the beginning, or slower than just coding all the logic in the view in Django and just creating your models there too, because why not? It's just a test. But if you don't think about these things properly, your code becomes hell to maintain. Like with more lines of code, as the time goes by, maintainability is not a straight line. It's exponential. What I show you was an example of architecture that we've used. I'm not saying it's perfect, but it has worked for us. When I joined, I didn't join so long ago. I joined the 1st of March. We were about 5 people in the tech department. We have 31 people now. And with this kind of architecture and setting things up, it has worked for us. And it has enabled us to scale, both on the code and on the people side of things. Also, keep your application flexible. Don't couple your layers. Try to decouple as much as you can. Nobody knows what your requirements will be in the future, so you cannot plan for those requirements because you don't know them yet. But you can make your life easier now if you create parts on your system that are easy to change or unplug from the whole thing when needed. Also have proper test coverage. If you're going to build a system in a way that lets you plug or unplug different parts of it or swap data sources, you need to make sure that your tests are covering everything. And you can do that with some level of confidence or a lot of confidence. We tend to run our tests a lot. We also do TDD in here, so if you want to attend that kata, probably it will be a good thing. It's a nice thing once you switch your mindset and start thinking on what you want your system to perform like instead of just coding just because. And also something that is really important is if you have a lot of tests and want to make sure that everything works, run your tests a lot. Run them multiple times per change. If you change one line, why not run these tests? Well, if they take 5-10 minutes to run, maybe don't do that because you will be not very productive. But as you can see, I don't know if that can be seen or if I'm in the middle of something. These are the whole tests for the Sales API project. These power the new Mundimoto website. And they take less than 2 seconds to run. So a rule of thumb would be, if I added a rule in my IDE to run the whole test suite on each save, would it bother me? If the answer is yes, maybe you should rethink about your testing strategy, because this should be okay to have it this way, to run the whole test on every save. Also have an infrastructure that works for you now, but also plan for the future. So it will be much more painful to throw everything to the bin in 6 months when you realize you've done things in a way that doesn't scale and need to do everything again. Even if now you feel like it would be faster to just do it fast and dirty, just spend some time. Maybe leverage it, but yeah, give it some thought. Also, be sure that if you're doing this for the first time or for the nth time, you won't nail it on the first try. Go little by little. When I joined, I spent a whole week working on a pull request for Sales API that had multiple endpoints. It connected to Monday, another data source. It had business logic all over the place, and it didn't have as many tests as I would have liked. When I opened that PR, I got so much backlash that I just closed it in the afternoon because I didn't want to deal with all the comments that I had on that PR. We ended up starting it from scratch again. I redid it, and then the final code that went into production had nothing to do with what I had written. So it still was a learning experience for me, and kind of it is that I'm trying to share this knowledge with you now. So don't worry about it, you will get it in time. And well, I guess we could be talking about this for hours because engineers like to sit around and discuss on how to do things. It's what we do, right? But even if I didn't go into much detail, my intention was just to give you some hints about what to expect when you start scaling up a system and need to know some do's and don'ts. When something that is more than a proof of concept that you're doing for yourself and you start working with a team. As I said before, I know that this solution might not be perfect, but it has worked for us. I hope that you can take something from this talk and use it, either in your projects or in your company. If it wasn't clear, we are hiring, so come talk to us, any of us. We are all branded today, and you can ask about how we build things and so. And if you want to discuss something in more detail, I will be around later for the beer and the pizzas, mainly for the beer. But still, just come around, have a chat, or if you have some questions now, just shoot them, I will try to answer. That's it.
How many requests per second do you hit?
On this system that I showed you, none, because it's still in development. So we have the two systems living at the same time. If you check the website, mundimoto.com, it's still the old stack. It's written in PHP, Laravel, and so. And this one, we have 2 Kubernetes pods working for internal testing. But it's still not live. Maybe if you ask me this question in a month and a half, I will be able to answer because that's when we plan to release it.
The old one, no idea what?
The old one, do you know, Sergi, the amount of requests that we get?
And like visits in our website or?
Yeah, let's say website, database, yeah.
We got around 7,000 visits.
Per second.
No, per second. We just operating phase. And it's all under by Firebase right now.
Kind of this is the idea behind this is that we want to operate on different countries. We wanted something that was replicable also and that we could reuse. So hopefully as we expand throughout Europe and so, the idea is that we scale. I cannot give you some numbers, but yeah, that was the plan. Yeah.
I have a question. You say that you were using Django models for the model domain layer. How do you handle the fact that in Django the models are quite coupled with database? Like if you have a Django model and you do dot whatever, you can access the database. So there's a high risk of like anyone in some use case doing model dot some relation and then calling the database directly.
We have a repository which is dummy, let's say. It's like a library that we import into our projects, and that's where the interactions to the database happen. So we have the create, the deletes in there, and the cleans, and what we build in our APIs are a layer on top of that, and we talk to those repositories. I can show you later if you want, but it's a bit weird the first time I saw it, but it works quite well, surprisingly. My boss wrote it, so I cannot say bad words about that. Yep.
What database engines are you using for SQL, NoSQL, caches?
You mean in AWS or?
MySQL.
Yeah, it's plain MySQL on RDS.
Do you think it's enough for scalability, or maybe later you will need to change this?
We checked Aurora. As for now, it works. But as I said, it has no real traffic or data. We are just copying all that comes into our current website into that replica. But hopefully, if everything that I said is true, if we see the need, we will be able to swap effortlessly with a lot of.
Thanks.
Yep.
I was going to ask a question related to this, and it was, why did you choose MySQL instead of Postgres, for example?
If I remember correctly, I think it worked pretty well in the AWS world. So as I said, we were in the define everything phase, and we started reading around. What we found out was that with this stack, although Postgres is usually the go-to with Django, in AWS, it had, I think, good enough performance, MySQL, to use it in our use case.
Yes, I did this question because, as you said, Postgres is mainly the de facto database used with Django, and there are also some fields that are only present using Postgres. For example, array field, JSON field, something like this that has more integration with Postgres than other databases than MySQL, for example. And this was curious to me.
Yeah. To be honest, it was. We didn't spend a whole week thinking about it. We wanted to have something. We wanted to access databases at some point because we started building the service from the API side. And when we started, when we saw that we wanted to save our data in our database instead of Monday, we read about it a bit, and we saw that MySQL worked well enough. Maybe Postgres could give us something else, the icing on the cake, I guess. At this point in time, I don't know, and I'm not sure if we need it for our use case.
Can I make another question?
Sure.
Do you use some queue systems for performing tasks in background, such as RQ or Celery?
Not now. No. So the database that we built in our squad, maybe there are other use cases on other squads, but we just handle the stock on the website, and this is not something that changes a lot and requires a lot of stuff like this. I cannot say about future projects. I guess we will have some queuing system at some point for some parts of the system. We haven't made those decisions yet.
Okay, so I suppose that you don't use Redis or something like that,
No.
or Cache, or you don't need it.
Not yet. Everything about this is on the works. Maybe we can have a chat later about infra, because there are a lot of things that are being built as we speak. The platform team is working on giving us something that we can work on, and from what I've heard, it would be pretty nice. So we will have Datadog, if I remember correctly. We will have Kafka for events and so, and we will probably have also some kind of caching in place to make use of. But I can point you to the right person later that knows more than I do.
If I may interrupt, we were running out of time for the question, so if you may take it to the later with the pitch.
Yeah, sure.
For
Sure.
the
Just
conversation.
catch.
Thank you very much, Samuel, for your.
Thanks.